Examples on Kirchhoff laws.
Welcome to another episode with Apply Electricity with King Solomon and because David. Today the last time we met we spoke on Kirchhoff's law, and today we are dealing with an example on Kirchhoff's law. So we are going to apply the KCL and KVL. So with the KCL and KVL, applying them to this, first let's distribute our current to this circuit. So in the distribution of current, we can see that from this voltage source, I1 will start the journey. I1 will get to this junction and I2 decide to take this route. If I2 takes this route, the remaining is going to be I1 minus I2. So after getting the I1 minus I2, I2 continues the journey. It means another load. So it is going to split again. And when it splits, I3 is going to use this branch, and I2 minus I3 is going to be here. So after distributing your current, now it is time for us to take our loop. So to take the loop, first loop will go this way. Then we have our second loop, our third loop. But from what I said the last time, I told you that when you take a loop and the arrow touches negative before positive, you are going to get minus 7 because it is touching the negative side before the positive side. Then if it is in the same direction with the current, that side is going to be positive. So I1, the voltage across this is going to be plus 2I1. Then it is in the same direction with I2 minus I1 minus I2. So that one too, we are going to get plus 3 I1 minus I2. And since there is no other term, the law says that the algebraic sum is 0. So we can simplify this and we are going to get 2I1 plus 3I1 minus 3I2 is equal to 7. And this is 2I8. This plus this is 5I1 minus 3I2. This is equal to 7. That becomes our equation. So from this equation, then that's the first loop. Let's come to the second loop. The second loop, as we can all see, if you take this loop, this arrow will be opposing this current. So that is going to be negative. So you are going to get negative 3 times I1 minus I2. Then the loop is in the same direction with I2. So you get plus 5I2. Then the loop is in the same direction with I2 minus I3. So you get plus 2I2 minus I3. Then the loop is in the same direction with I2 over here. So you get plus 2I2. And this is equal to 0. So after getting this, you simplify everything. This times this, we get negative 3I1 plus 3I2 plus 5I2 plus 2I2 minus 2I3 plus 2I2 is equal to 0. So this plus this is 8, 10, 12. So we have 12I2 minus 3I1 minus 2I3. And this is equal to 0. So this becomes our second equation. So we are done with loop 2 and loop 1. So now let's go to loop 3. With the loop 3, we are going to get, this is opposing this carry. So you are going to get minus 2i2 minus i3. Then it's in the same direction as this. You get plus 2i3. It will touch negative first. So you get minus 10 is equal to 0. So this one too, by simplification, you get 2 minus 2i2 minus a plus 2i3 plus 2i3 is equal to 10. So you have 4i3 minus 2i2 is equal to 10. So this is our equation 3. So we have 3 unknown variables, I1, I2, and I3. And we have 3 equations to solve the 3 unknown variables. So since we have 3 equations and 3 unknown variables, we are going to solve this equation. Okay, so after getting the 3 equations, which are 5i1 minus 3i2 is equal to 7. That's our equation 1. We have minus 3i1 minus a plus 12i2 minus 2i3 is equal to 0. That's our equation 2. Then we have the last equation, which is negative 2i2 plus 4i3 is equal to 10. That's our equation 3. So you can solve these 3 equations simultaneously, and you get I1 to be 2 amps, I2 to be 1 amps, and I3 to be 3 amps. Thank you for being with us for today. See you on another time.